Hello, everyone. My name is Mihaela Bucur, and I'm the lecturer responsible for the Industrial Engineering and Management department within the engineering faculty. And I'm the one who created the esteemed local group here in Târgu Mureș in 2012. This is a special week for the academic community in George Palade Emil University of Medicine, Pharmacy, Science and Technology of Târgu Mureș. So this pandemic situation gave us the opportunity to organize this special event, which brings pride and honor to our university. On behalf of the academic staff and participating students, I would like to thank our special guest for accepting our invitation, and I'm sure that students will learn new useful things today, which they can afterwards apply in their daily lives or their workplaces. Thank you very much, and I'm waiting Greg to tell us more words. Thank you, everyone.
So I guess this is my cue, and I am going to now share my screen because I always seem to have PowerPoints for everything. And I just need to go to the full screen mode and move all these pictures off to the side so I don't get too distorted by this. Okay, well, thank you all for inviting me to the university today for University Days. And you gave me a topic I don't really like to talk about, me. And I was trying to figure out, what do I call this? Do I call this quality in me? Do I call this, a blast into my past? What do I think about this thing? And the difficult thing in talking about yourself is you realize that you're getting older. And so the thing that this got for me is I started thinking that I'm really going back to the 1980s or so when I first became definitively involved in quality. And so what I thought I'd do was talk about a few topics. So first I would talk about what do we really mean by quality, quality management, quality development, quality improvement, and Lean Six Sigma. So these are all topics that if you're not familiar with quality that have evolved over time. And so I want to give you a baseline to understand what it is that we'll be talking about. And then I'd like to review my career path. What brought me here in the first place? So what has it that's brought me to this point in time in my career when people actually want to take this Greenbelt course through Esteem and to get some certification as a start to your career? And then I'm going to reflect back over the last 45 years that I can talk about being directly involved in quality and hopefully having made some contributions in shaping that. And see, what are the changes that I've seen in this field over those last 45 years? And as we look back on that, I will take a look in particular about some reminiscences. This is the sort of thing you do at the beginning of the year for New Year's Day. Typically we think about what the past has been, what the present is, where are we going in the future. We start making some resolutions about things that we'll do differently. And so I'm sort of beginning that a little early, and I'm going to go back and talk about my first quality experiences at Hewlett-Packard back in 1984 when I left the US Navy and joined HP. And then I was director of corporate quality at Compaq Computer, vice president of quality at Xerox. I started my own consulting practice and spent 5 years consulting to Nokia, about 18 months with Toshiba, and 2 years with ExxonMobil before I moved to Finland on a full-time basis. And we're going to then give you some background on Six Sigma and what have been the developments that have happened since this methodology basically became evolved starting in 1985 to the current state that we're at today. And then finally, we'll come back and we'll talk about what this means for you. What are the challenges of the current state and what sort of recommendations can I make for you about decisions you might want to make about your careers in the future. So that's sort of the pathway that I put together for our discussion today. And hopefully you'll get some questions generated and we can have a good conversation, you know, as we get to the end of this. So what is continual improvement? So continual improvement is basically an idea that it's been around ever since humanity began. You know, we started thinking about people not liking to walk everywhere, so they invented a wheel, and then they started figuring out how can we be more efficient about wheels moving, and we had motors, and then motors went from injection engine motor to our internal combustion motors to electric motors to big generator systems and so forth. And now we're getting all sorts of things happening. And so continual improvement, apart from just being the way people think and act, as a management discipline, it was actually introduced back in 1916. At that point in time, Henri Fayol wrote a book, General and Industrial Management. And this was really about the time of the renaissance of industrial engineering. So industrial engineering really became a unique discipline around 1896 or so. And that's when the first university started founding schools of industrial engineering. The school I graduated from, Oklahoma State University, was the third oldest school of industrial engineering in America. I know that in China, they had a school also in 1906 at Shanghai Xiaotong University and so forth. So in general, we're talking about a discipline that's just a little bit over 100 years old. And this idea of emphasizing continual improvement is really part of industrial engineering. It's part of the quality discipline within industrial engineering. And industrial engineering has enabled this to advance as a disciplined activity on structured improvement. So it's the industrial engineering approach to continual improvement is about applying a scientific method to have structured improvement. And in 1923, Walter Shewhart created the statistical method for control charting or process control charting as a way for us to document the improvements that are happening in processes as they develop over time and as we watch how they progress from the beginning of the process to the end of the process. And so this is basically the foundation for this concept of continual improvement. And when we look at this over the 20th century, we can see that while continual improvement has been a focus from the very beginning, when we started talking about Frederick Taylor, and basically they were just looking at something called a work breakdown structure, just trying to understand the tasks and work and how can we make them simple. We started seeing time and motion studies being developed there. They started creating flow charts, inspection at the point with measurement devices that were basically handheld. We saw the birth of the Gantt chart and so forth coming out of the early 1900s. And then statistical process control in the 1923s. And as we went further into the 1930s, 1940s, it was basically just inspection-based statistical quality control. The first standard that was written was in 1935 by Egon Pearson. It was British Standard 600, which became a foundation for BS 5750 later on, which is then the quality standard you all know as ISO 9001. After World War II, we started seeing there was a renaissance, if you will, of interest. And we started seeing the birth of a lot of ideas as the Japanese started creating a structured approach towards developing this quality discipline and creating a structured process of what they called total quality control. It wasn't called that right away, but they were just trying to understand. So they created quality circles. They created the basic quality toolkit of 7, if you will, analog tools that were used by hand calculations. And they created the Plan, Do, Check, Act process in 1959. That was a Japanese creation by Shigeru Mizuno. It was not created by either Shewhart or Deming. They inspired it, but it was a Japanese creation. They created basically standard work processes. These were improvements over the American Training Within Industries process, which was created in World War II to teach people how to do standard work in production processes. then later on came just in time. That was happening in the 1970s. In 1973, there was the global petroleum crisis, and there's also the change in the monetary standard from a gold-backed standard to a floating rate, and the Japanese took a double hit on that because they import all their fuel, and they then had their system pegged to the US dollar, and they went from 300 yen to the dollar to 100 yen to the dollar, and it created a financial crisis in Japan. So they could no longer afford at that time to have waste in their systems. And even though they had been encouraged for years to eliminate the waste, this was a stimulus that created that. There's a secondary thing that happened, and as industrial engineers, I think is perhaps more important than the economic incentive. And this was that in 1973, Toyota put in place point-of-sales terminals. So in other words, they were for the first time connected through terminals at their dealer channel through a central computer over a telecommunications network, which at that point in time was telephone line, twisted pair, 56 kilobyte. But they could then transmit orders directly to the factory. And that created the pull process. That enabled just in time to be able to create the order pull. And then they had the systems pull, which they had to do manually at the time. And that was the birth of the Kanban system. So we see the 70s was really the development of much of what you all have heard of in terms of the Toyota production system. So we see value stream analysis happening at the same time, total quality control, just in time, all of those basic quality components. And value stream analysis then allowed them to see where are they having waste in that process. In the late 1970s, we saw benchmarking being developed. It was developed originally by Xerox Corporation, but it was developed in a joint venture with Fuji Xerox. And in 1975, Xerox had been very successful, but they had been declared a monopoly by the United States Supreme Court. And so they were forced to divest, if you will, all of their patent technology. So there are 2,500 patents they had to put in public domain. And the Supreme Court ruling also ruled that because they had this virtual monopoly, they were also considered a predatory corporation because they also had a price monopoly. And because of that, the penalty was that any company that came forward wanting to know how to operationalize all of those patents that were now available to everybody and build competing products, that they had to show them how to do it. In that process, they discovered that their systems were very, very, very inefficient. And so in 1975, the net return on assets of Xerox, their profit measure, was about 25%. And by 1979, just 4 years later, it had gotten down to 7%. So they were bleeding, if you will, financials. And in their benchmarking, they discovered that for some of the small systems, which they hadn't paid attention to in the past, that their manufacturing price or cost was essentially the exact same as the marketing price of Canon for those small systems. And that started the growth of Canon as a major competitor to Xerox. And we see then at the same time, Six Sigma was developing around 1985. We'll talk about that in more detail. Along came quality function deployment in the mid 80s. 1987, the quality standard came about. The Japanese then brought forward Standardized Do Check Act, Planned Do Check Act as capabilities, attractive quality by Dr. Kano, and then the lean enterprise concept was created by Womack and Jones. And then the Japanese called this their whole system, they moved it from total quality control to total quality management. And so basically that's where we were. Oh, excuse me, I should add one more thing. 1987 was also the Malcolm Baldrige National Quality Award of Business Excellence. And that was basically the stable state until 2003. And in 2003, the term Lean Six Sigma was coined. And so this is what we see. Now, all of those initiatives are basically addressing exactly the same condition, and that is the need for continual improvement. That is the what is happening. And then how is happening is all of these other methods. And so we see there's a lot of innovative ideas, a lot of things happening in the process, but it's a very different thing. So we see that there's a long history of continual improvement. And so let's now back off a little bit and say, okay, what do we mean by quality? Now, if you look up quality in Wikipedia or in some sort of computer search, or you start reading supposed gurus of quality, you'll find out that each of them has their own definition. And all of those definitions are actually basically a subjective perspective. And so some of them will say it's customer satisfaction. Some will say it's conformance to requirements. Some will say it's the price of non-conformance and so forth. So there's all these definitions, and they all are lacking in several things. Number one is they do not really give us a perspective that allows interpretation in different ways. For instance, if you say it's customer satisfaction, which customer? What do you do if you dissatisfy one customer while satisfying another? You're giving one good quality, the other bad quality. How do you choose? And so there are many problems with this. And the reason that we have the problems is it hasn't been thought out as a system. So we're going to step back a little bit and say, okay, we need to have a transcendental, or what I call comprehensive definition of quality that applies to everything. In other words, it can go any way in terms of which way we're looking at it as we're trying to just decide what we're going to do. So in this perspective, I've defined quality as the relentless pursuit of goodness. So this is doing what is right, delivering what is right, but it's coupled tightly with the persistent avoidance of badness. And so what that means is that if I'm doing good and I'm also doing harm, I don't have quality. So we have to think about this in the broadest possible way. And as we think about that, what we start seeing is, well, how do we apply this in different applications? So this is a metaphysical, if you will, definition. It's a very holistic, it's not concrete in terms of how it's applied in the real world. So we have to then take that definition of this pursuit of goodness coupled tightly with the persistent avoidance of badness and then apply it in the contexts. So the contexts are basically threefold. They relate to products, processes, and services. And if I'm talking about product quality, I'm identifying goodness and badness with the actual entity, the thing that's being produced. So I can say this is a good car, this is a bad car. And then I can have physical criteria for how I judge goodness and badness. And then we can actually factor that into how we do the design and how we do the operations. If I'm talking about service, I can talk about service, goodness, and badness relative to the actual experience that a person has in getting that service. So if you go to a hotel, for instance, and you're getting a service of given a night to room, you know when the hotel is clean and you know when the hotel is acceptable to you and when it's unacceptable. And every person can make that sort of judgment between this idea of the good and the bad. If we're talking about processes, there we're talking about this idea of this goodness and badness in terms of the actual activity. What's happening in that work? What's going on that we can actually say this process is operating properly or improperly? And so each of those requires us to think about quality in the context of this juxtaposition between good and bad relative to the particular context in which we're applying it. So as we come down, we say, okay, for each of these in transcendental quality, we have product quality, service quality, process quality, and we can break those down into how they're being applied. In product quality, the actual entity, the thing produced; service quality, the actual experience, it's what you get out of the particular service; and then the third, process quality, is the actual activity. And then furthermore, we can decompose those into the specific quality outcomes or the result characteristics of the experience or the entity or the activity. So after we decide what type of quality we have, then we can figure out what's a desired set of marketing features or the design functions that can be used to establish the outcome or the result that are requirements of customers. And customers include both intended and unintended types. So we have the customers that we target and then the people who declare themselves to be our customers. And requirements when we describe them, have to be stated with a number of ingredients. The first is who? Who is the customer? Who is it that we are responding to? The second question is what? And here we're talking about the function that we are delivering. What is a noun verb phrase? And in value engineering, that's how we describe a function. It's a noun being acted upon in a particular way, which is the verb. And then we have to answer the question, for what benefit? What is the thing that they get out of this deliverable? And then we have to understand how will it be measured? And then finally, we can set the standard for, and what is a good measurement for evaluating that type of benefit? So we can break down the specification of how quality is delivered very precisely by following that type of structure. Now, Joseph Juran, in his early writings, he's one of the major quality authors in the past, he talked about the quality trilogy. And he said that it's just like in finance, where there's financial control, financial improvement, and financial planning. Quality also has quality control, quality improvement, and quality planning. And Dr. Kaoru Ishikawa, who was Japanese stimulus, if you will, for thinking about quality in a particular Japanese style way, he drew this diagram that I'm showing you here. So we're looking at a particular performance measure. So you see the normal distribution there on the left, and it's going from unacceptable to a better condition. And at this base level, we see here there's a lower specification limit. Below that is unacceptable quality level. That is quality customers will not tolerate. And what we see is that the job of quality assurance in an organization is to hold that level of performance and not let the quality get below that. So that's really what we are trying to do. We're trying to assure that customers get quality that is above the minimum acceptable level. The job of quality control, we see, is tied to the operating average. And so here what we have is we would like to make sure that we control the performance so that it is able to deliver quality in a predictable, consistent manner, that it happens stably over time. And then we see the job of quality improvement is to push this performance up to its natural process limit that is consistent with the cost we're able to bear. So quality improvement is driving us there. And so we see there is this blue zone over to the right called the quality delivered zone. This is the zone in which we should be operating to deliver quality to customers. Now, we see we also live in a competitive environment. And what we find out in competitive environments, as we can see today, is that clearly over time, things change. And one of the changes is that the technology shifts, and it causes us to move quickly in a new direction. And so sometimes we start saying we have to move our performance beyond the current domain into a higher level of performance that's desired. And this takes us up to the last zone, and that's quality planning. And to get into this performance range, we have to have innovation. We require a different way of looking at things and a new way of understanding. How do we use our material? How do we apply our processes? What are the tasks that people do? And Juran made a comment when he talked about this in the early 1950s. And he said, without a standard, there can be no improvement. If we don't have that base established for quality assurance to know what is acceptable and what is unacceptable, we cannot actually begin this improvement journey. So the journey has to begin first by understanding how do we set that base, and then being able to track our performance as we move upwards towards the limit of our capability. Now, I go back and I start thinking about quality, and I joined Hewlett-Packard right out of the Navy. I'd spent almost, I guess, 12 years almost in the United States Navy as an officer, as lieutenant commander when I left. I'd done a lot of work on computer systems and engineering tasks. I'd been a program manager and also designer. I had a few patents. And at that point in time, I was thinking about reliability. You know, can I make systems that will work well? I didn't really think about quality. For me, quality was just the component of reliability you're delivering. It's not necessarily something that was standalone. And so we thought of it almost dominantly as product quality. It wasn't about the service itself. It wasn't about the process. Yes, there were control charts at that point in time, but they were basically just used to make sure you delivered the product quality. And that was the thing, as we were taking a look in those early days in the 1970s up until that point in time. Control charting was basically about the product, not really about the process. Now in Japan, that wasn't quite true. Now, as I start taking a look at what's been happening over the 45 years, I see that basically the first thing is that there was emergence of Japanese quality and productivity systems. These became accepted, if you will, in the 1970s and early 1980s as the best case, the benchmark, if you will, of quality across the whole world. And so everybody wanted to emulate the Japanese. In 1981, Hewlett-Packard received the Deming Prize in its Yokogawa Hewlett-Packard division. That then became the model for how it would actually apply quality in the decade to come. And the interesting thing was that the organization was new. HP bought it in 1976. It was formerly the Yokogawa Electric Works. HP bought it. And at that point in time, it was the least profitable division of all HP divisions. And what happened over the next 5 years is that the chairman, Kenzo Satsuoka, challenged the Deming Prize. And he says, I want to win the Deming Prize. Now, the reason you win the Deming Prize is to improve, not just to get the prize, because you can't win the prize by gaming it. You have to win the prize by performing. And in 1981, when they won that prize, they had moved from the least profitable division inside of HP to becoming the most profitable division. That was a wake-up call to HP. I'll come back and talk about that a little bit more. We also started seeing that World War II gave us a very strong impact of moving science into the operations field. So maybe you've heard some of the stories of the radar systems or the code breakers or the ship riders in the US. So the US Navy had ship riders. They put scientists on the ships to try to figure out how can we do warfare in a more scientific way. And that improved the way radars were used, the way sonars were used, and the way operations were controlled. And that was a technical maestro. So that person was on board because they understood physics and math better than the people in the operations. And they could apply those methodologies to create a more collaborative effort among the team that were the warfighters. And so we have changed, though, from that technical maestro to a team collaboration. We've now distributed the technology. And that's another significant change that's happened. It's no longer do we look at the statistician as being the expert. We've democratized statistics and made it available to everyone. And this is one of the big changes that happened through Six Sigma, if you will, because now we have statistical tools that everyone can get a basic understanding of how to interpret statistical analyses. We also saw that development of benchmarking happen. And this was a very important development. So this came about in the late 1970s. I got involved in that in the early 80s. And what we started seeing was that all of a sudden we had to pay attention to how do we have performance measurement across companies. And so benchmarking is where you actually take a performance measure and compare it across different companies to try to discover who has the best process for doing something. So most benchmarking is process oriented, if you will. But the requirement for that was that we had to have the same comparative performance measures at each company. And that means we had to be able to make a baseline so we could understand we're comparing apples to apples, not apples to oranges or lemons. And so this focused management on this concept of performance measure in a way that had never been done before. We also started seeing that after that, improvements were happening in these benchmarking processes as business-wide quality initiatives. Originally, Xerox had benchmarking as an independent activity, and then they moved it into the quality community. So it became part of how they managed change. So in the early 1980s, they had 4 major processes. They had an employee involvement process. They had a problem-solving process. They had a continual improvement process for making projects. And then finally, they had a benchmarking process. And those 4 processes, they taught to all employees. So everyone knew how that work was being done. And that was the system that they had created for what they called business excellence. We also see that there's a tighter linkage to the more scientific analytic methods. So statistical designed experiments and statistical control, multivariate analysis, ANOVA regression, all of these technologies started coming to play in the 1980s. When Kaoru Ishikawa talked in 1987 about basic quality tools, he didn't talk about the 7 quality tools. He talked also about ANOVA and regression. Now, at that point in time, ANOVA and regression were not tools being applied in America. So they were not tools in the system. As a matter of fact, in the first generation of Six Sigma, regression was there, but ANOVA was not. And so we start seeing that there was a spotty, if you will, application of even advanced statistical methods. And then we started taking a look at these in terms of multivariable statistical techniques. How do we do multiple variable techniques? Now, again, at the time Ishikawa was talking, most applications were what I call univariate. We took a look at one variable changing over time, or took a look at defect rate and we counted how many instances did we have. But when we actually did the statistics, we're only looking at one factor at a time analysis. And so what we started seeing was, how do all of these factors start varying together? And as we moved into this, we started seeing the need for more advanced regression technologies, multiple ANOVA types of tools, and more extensive use of applications of statistically designed experiments and Taguchi methods. Then we start seeing the application of Bayesian statistics and probability theory. Now, these are not even in the Six Sigma body of knowledge, but I do basically teach about them in terms of how we deal with things. But every time we have a problem where there is a precursor process and I'm worrying about what will be the predictive future, that can be described as a Bayesian problem. So a Bayesian problem is I'm taking a look at what's the probability of a future event based on a past event having occurred. And so we start seeing probability theory is tied into control chart theory, because control charts are trying to figure out how do we control the future based on the observed variances and causes of variance that we see from the past. So Bayesian statistics is going to be a technology that becomes adopted into the statistics, and it's just happening now. And we also start seeing there's an expansion of the influence of customer chains. I think we're getting smarter and smarter about looking at material chains going all the way back to Mother Earth. Toyota calls this a plan for every part. And we start seeing, well, how does that actually change from raw material into a subcomponent, into a part, or like a printed circuit assembly, into a sub-assembly, into a final product, and then into a system as it gets out the door. And we start seeing how all of that starts fitting together. And so we've seen lots of these developments happening over time. Not every organization understands them, not every organization does it. But as an enlightened quality organization, we'll start having all of these as part of their toolkit for how they make change happen. Now, when I take a look at this development of continual improvement and I compare it to my career, what I see is that in my days at Hewlett-Packard, I basically saw the change going from a fundamental work breakdown structure, which is about as advanced as what we were doing in the military, into the Six Sigma QFD, total quality control benchmarking environment. When I moved to corporate director of quality at the Compaq Computer, attractive quality came into being, lean enterprise, standardized do check act, HOSHN, and the ISO 9000 standard came into being. At Xerox, TQM evolved and it converted into business excellence. That term was actually created at Xerox when the Rank Xerox organization applied for the European Quality Award. And the very first business excellence model actually came out of Xerox, at which point in time it was then modified for use in the EFQM model. And then finally, after I left Xerox, I had some reasons for leaving the corporate world due to my health, and we started seeing Lean Six Sigma coming to bear. And so in each of these different phases, I've seen changes happening in the quality community. So what I want to do is go through some reminiscences, if you will, from each of these different periods. And I talked briefly about Yokogawa Hewlett-Packard, and they're receiving the Deming model in 1981. And when they received that medal, it established, if you will, a role model for quality. And that role model was in terms of how quality is implemented, embedding standardized work, business fundamental measures of that standard work, how those business fundamentals convert into measures of profitability as a predictive analytic estimate, and how the management then identifies what are strategic change projects and then deploys those as a Hoshin improvement project. All of that was built into Yokogawa Hewlett-Packard in 1981. Now today, many organizations don't do that. And so, we're talking about lessons learned of 40 years old that need to be discovered by many companies in terms of how will we make those changes happen. Now, the initial effort of Hewlett-Packard in replicating YHP failed. And I have to admit some responsibility in that. Because what HP USA tried to do was they sent a team of people to Japan to observe their processes and bring back the methods and say, let's then take these to everywhere in the company and let's expand them into our use and integrate them so they become a part of the culture of what we're calling total quality at that time. But the thing is that when we started doing this, we didn't understand the culture or the integration that was happening. We concentrated on just-in-time production, and I was deeply involved in that because I was at the San Diego division. We were developing inkjet technology. The two major projects under development at that time was PaintJet, the first color inkjet printer, and what you now know is DeskJet. They were in R&D. One was Squirt, that was the PaintJet. Squid, with multiple tools. It was the DeskJet. Both of them were ready for market in 1987. Now, HP didn't launch it, the DeskJet at that time. They launched it in 1991. And what we started seeing was that the concentration we had was on just-in-time production. And we looked at this, we saw we could make many, many significant changes. And we started doing analysis. So one we did was on injection molding. And I had this as a project to create a just-in-time injection molding system. And in one of the recent, I guess it's a webinar that I delivered, I discussed this as a case study and how at the time we started, it took 4 hours to change a mold on an injection molding machine. And what we did was we had 22 different molds we had to change on a machine if we wanted to have a efficient operating system. So we had basically for one electronic machine, a niche machine, first came out of electric machines in 1983. And we wanted to equip that machine with everything we did to reduce the mold changeover time and make that productive time. By the time we were done, we'd moved it from 4 hours to 7 minutes. And if anybody's interested, I think if you are not already on my LinkedIn, go to my LinkedIn. There is a case study that's published there as a webinar that you can see the details of that in a couple of PowerPoint slides. And it's just basically sound industrial engineering, by the way. So it's not a big surprise. But what we did was we had the payback period in less than a month. And so as you start taking a look at this, you make significant improvements by implementing these technologies. And we realized that at that point in time, emphasis should be placed on the system design, not on methods and tools we select. So it's better to use a homegrown tool than to copy what other people's have done. And when we looked inside of Japan, we saw that's exactly what the Japanese did. Yes, they had a generic PDCA model, but guess what? Every company had the detail different. And this is, I think, something as you start studying the different companies, you start seeing, yes, they all said PDCA, but how they did it was different. It was based on their business. It was based on the types of challenges that they had. And so one of the lessons I learned at that point in time was how can we actually create a system that works for us? And the answer is do not copy. Take what they have done and adapt it into what you're doing. And this, I think, is one of the big lessons that I tried to get across in Summer Academy to those of you who may have gone to the summer academies that I taught. And that is, if you're going to be in industrial engineering, it's not a single size fits all. It's every organization has to have its own approach that fits its industry, its business environment, and the competence and capabilities of its people, as well as the amount of money or resources it can invest in the future. Another thing that we saw at HP was that internal communication is a significant success ingredient to achieve cooperation. So HP had in its tradition something called management by wandering around. This was popularized by the 1981 book by Tom Peters and Bob Waterman called In Search of Excellence. And In Search of Excellence talked about MBWA and about how the executives would go around and talking to the other people in the organization to learn what was going on. Now, this became the basis for what Taiichi Ohno implemented, and he cites it in his book, Workplace Management. He said that he learned about it from the 1981 book from Tom Peters and Bob Waterman. And so he talked about Gemba walks. Now, we have to realize, what was the purpose of MBWA? It was for the management to go around and find out, what do people need to improve? What are the things you're doing? They were asking the question, how can I help you in doing your work? It was not being done to try to say, I can help you by telling you how to do your work better. And so fundamental in this ingredient was a communication process. It was to open up the door so you could listen to people and their frustrations and the problems they were having, and try to find out, what could you actually do? Did they need decision rights so they could do things better? Did they need to have some sort of investments? Did they need training? And what was it that they needed that you could actually bring them? And Taiichi Ohno in Workplace Management, he said, never go to the Gemba empty-handed. Always go asking, what can I do for you? Go to help them by doing those things that you can do uniquely, which they can't do for themselves. And the final thing that we saw was the way to start just in time. The way to start any sort of lean system is not 5S. It's not value stream mapping. It's actually understanding setup and changeover times and reducing it. Because the bulk of most time in any productive process that has not been optimized is in setup and changeover time. And so this was the thing that we did in that plastics factory. We changed the changeover times. And in so doing, what we got was 22 mold changes in a day instead of 4. And that's a very big difference. You can measure that in terms of capital equipment, that I would have had to have 5 more injection molding machines under the old way to do the same thing. So as you start thinking about it, the first place to do is take the bulk of the waste out of the system. And in any sequential production process, setup and changeover time is a very major ingredient. And that's the place to start. I could talk about 5S and why it's not the place to start all day, so I'm not going to go into that right now. Maybe that's a question you all will have later. But what came out of this learning is the understanding of what quality management is. And first of all, it's a systems approach. So it is quality assurance, making sure that you do not have the failure conditions. That's protecting customers from failure states. It's quality control. It's establishing a stable, consistent process for performance. And it's quality improvement, to keep ratcheting that better so that we get better performance results in terms of quality, time, delivery time, cycle times, and productivity and safety and motivation. And when we put all of those together, that's what we mean by quality management. So quality management is doing all 3 of those simultaneously. And what we see when we do that this approach optimizes the investment that's already made in a management system. We don't need to add anything to it. What we're doing is we're squeezing out, if you will, the waste that's embedded in processes. We've allowed that waste to grow up over time. And so we want to get rid of it. Now, when I think back to Compaq Computer, I joined Compaq after HP. I'd been in corporate level at HP, I was the program manager for quality leadership development, introducing new technologies into the company like Ocean and QFD, benchmarking. And at the same time, I was responsible for training the quality managers in the company as well as the executives. And when I got to Compaq as the director of corporate quality, I now had total responsibility, including the production, service operations, sales, and so forth, and R&D functions. And when I came into Compaq, the company had been founded on 5 dimensions of a culture. And each of that was set to gain competitive advantage so they could win in the computer industry and to continually improve. Matter of fact, in the very first annual report, Rod Canyon, the founder of Compaq, said that we aim to be the quality and reliability leader in the computer industry worldwide. That was a stated objective of the company. So what were the 5 values? The first was putting the customer first. So we will make sure that we're doing things from a customer perspective, not an internal perspective. The second was working in teams. So we're going to have a collaborative approach, not just go one person at a time, but actually being used to build teams to do everything. Third is we will do what makes common sense or do what makes sense. And so this is saying that we have to have an approach that you can tell and explain to everyone in the organization. The fourth was we'll manage by facts. And that gives us an objective way of making those choices. But it also then says facts are important. We have to analyze those facts and understand those facts. And that became the basis for our application of Six Sigma. And we have to pursue achievement. But you cannot exist as a company unless you can generate profitable growth. And so those 5 cultural elements were reinforced every day in how we operated and the operating philosophy. And we added to that, we should work with a sense of urgency. Try to get things done as fast as we can. As an example, when Hewlett-Packard decided they needed to have a service operation in Europe because it was selling a lot of computers in Europe, it was gaining on Nixdorf and Siemens and Olivetti at the time. And so ultimately it put almost all of those out of the computer business. But to service them, they were having to send their computers back to Texas. That wasn't a good idea. So Compaq made the decision, we're going to put a service center in Texas, in Europe. And so you'll never guess how long it took to do that. So from the time the decision was made till the time the first computer was accepted and being repaired was just 30 days. And so that's the idea, do something with urgency. Well, they had to establish a site. So they established that site in Erskine, Scotland, just outside of Glasgow. It had been a site that Wang Computer had already built, no building required. It was vacated because Wang had actually shut down before then. And so we had a computer site. So we bought the site, we closed the deal, we sent people over. We started then multiple tracks all in parallel, recruiting people to be trained, training people, developing the procurement requirements for all of the equipment, getting the equipment in, sending the people to set up all the logistics to move computers in and out, and then full scale operation just 30 days later. And that was the kind of move that Compaq was used to doing. And it was built into its way of operating for everything. So they consistently pushed the envelope of reducing time to market for new product development, reducing time to get to customers for feedback and so forth. Now, before I left Compaq, there was a distribution chain crisis in 1990. And what happened, the Compaq business model was to sell to 10 distributor channels across the United States. But as you may know, back at that same time, there were some other companies like CompuAd, Dell Computer, Northgate Computer, and so forth. And all of them were selling direct to customers or had their own bricks and mortar stores. And this was making a significant change to how computers were being distributed. And it put a profit crunch on the dealer channels. And in just a 2-week period of time between the middle of March and the 1st of April, the 10 dealer channels in the United States consolidated to 5. And what that meant was that there was 400 million too much of inventory in their warehouses. Now, the business model of Compaq at that time was we sell to the dealers, and that's where we get our profit. The dealers basically get their profit in terms of the after-sales service, warranty, insurance, and so forth. And so what happened is that basically we were selling in a lot size of 1,000 computers. That's how we made them. We had a highly efficient production process, but it was not, if you will, just in time. It was not built in lot size of one. And so what needed to happen was we needed to move from a batch production system to taking orders on a telephone line as fast as we could. The stock price at the end of that 2 weeks had gone from $86 a share to just under $50 a share. The company was in crisis. The chairman came into management meeting and said, what we have to do is we have to then fire 20% of the people. And I objected. And my objection was based on the fact that the problem was the business model, it wasn't the people. And he gave us basically 6 months to fix the system. And in those 6 months, we did 4 major initiatives as Hoshin projects, combining benchmarking and structured analysis, structured problem solving to make those things work. And what they did was they applied our quality methodology we developed at that time. It was based on benchmarking. It was using DOE. It was using experimental design and our own internally generated version of Six Sigma, which did not really exist in public at that time, although it was in the process of being developed. So I'll come back to the development of Six Sigma in a little bit, and I'll talk about that. So we defined each problem operationally. We used benchmarking to establish external knowledge, and we developed all the change activities as a system. So it wasn't 4 individual projects. They all had to work together. So we had to make sure that they worked in a consistent, coherent information technology to support the operations. And that change happened. The net result was revenue before the crisis was 3.6 billion. Revenue after the crisis was 7.2 billion. It doubled. And so we actually did that with fewer employees. We didn't go fire 20%, but there was a natural attrition of approximately 5% of the employees. Now, what we see is there is a process that we go through. So Juran had said, without a standard, there can be no improvement. And what we see is there are levels of learning we go through as we start trying to understand what do we do to improve. So we start off with an out of control condition. And this is a model that I wrote about in my 1994 book, Business Systems Engineering. And it came out after we'd gone through the Compaq lessons, and I had discovered this process. I say, okay, the first time that we actually take a look at an improvement effort, the first time we go through a cycle, we're not ready to make improvement. We have to just learn to understand. What is the system? Where is the variation? Where is the muda? What's actually going on? How do we get the results? Where are the bottlenecks? How do the flows operate? And then the second time we go through that process, we're actually moving through our, if you will, triple loop learning process that I've talked about in the past. And now we have the ability to document what we do. We understand it, we've seen it applied, now we can document and create a standard. And now that we have that standard, we know what we can do to make improvements to change that standard. And so we're simplifying the documented system by eliminating waste and losses and variation throughout the process. And once we've gone through that cycle 3 times, now we're at a point where we can automate. And one of the biggest things that I've realized after that's now 27 years ago, is that many times we automate the wrong things. And we do that because we don't understand the system. We automate what we see or what we perceive or what we were doing before, but we need to simplify it. We need to make it improved, and we have to have a standard from which we automate. And so this is, I think, one of these cycles of learning that we have to go through. So this is about the development of quality. And we see that when we talk about quality development, we realize that organizations have to design the system that will deliver quality into the future. And so that means there have to be appropriate investments in resources, as well as the planned development of competence in its people. So that's quality planning. And then we add through that some sort of breakthrough improvements. These are new technologies, new methodologies, new ways of doing logistics, new IT systems, new communication processes, and so forth. And then we have to have quality by design. We have to put this together. We have to actually design that system so it works together. And when we do that, that's what we mean by quality development. So quality development is going beyond quality management. And what this approach does is it prioritizes the resource investments that are required to develop the management systems that we need for the future. And so quality development is a secondary activity we add on top of quality management. It's not duplicating. It's actually taking us to a higher level. This is really what we associate with many of what we call Hoshin-Conry types of projects. Or maybe you can think of them as either an advanced lean project or a Six Sigma type of project that's being done. Now, this brings me to the point in time where I joined Xerox as the Vice President of Quality. Now, my relationship in Xerox actually goes back to 1985 when I was at the San Diego division of Hewlett-Packard, the printer plotter division, a hard copy graphics group. And the folks at Xerox had also a printer process, but it was not competitive to ours. They didn't compete in any market. And they were interested in what we were doing with this implementation of just-in-time and TQC. They were located in El Segundo, California. And basically to do this, I said, yeah, I'd be happy to benchmark with you. I was a planning manager at that time for product line 30. And but I want to learn about this benchmarking thing. Can I join your class? So I did. And starting in 1985, I was a benchmarking partner with Xerox Corporation. In the late 1980s, when I was at HP Corporate, Xerox was interested in learning about Hoshin-Conry. And I shared the methodology with them, and I helped them develop it with their benchmarking network. And then in 1993 or so, I joined, 1992, I guess, I joined Xerox, and they were in the midst of doing a transformation. And they had two concurrent transformations happening. Organizationally, they were changing from a singular group where every function reported to the CEO, David Kearns, to having a divisional structure where there were 9 operating units, each of the CEO, the vice president of each of those units reporting to the new CEO, Paul Allaire. And that was because Paul Allaire was a finance guy who wanted to run a portfolio of organizations, whereas David Kearns was very hands-on and understood all of those different aspects and had capabilities in each one of them. And one of the things that this points out is that executives often have to restructure the organization so they can understand and apply it. And the second tech change that was happening was, in addition to the organizational one, was the technological change. But up until that point in time, all of Xerox's systems were analog. So maybe your parents can remind you of when the copier had a light. And when you flashed the light, it took a picture, it put the image on a rotating drum. The rotating drum then transferred that image onto a piece of paper. It came out and it went through a fixing system where it fixed the ink onto the paper, and it came out at the end, and that was the Xerox system. Now what we have is we have a digital system where it basically takes a photograph and transfers that digital photograph onto the paper. And so that then became color copier and color printing capable through the digitization process. Well, Xerox was going through massive changes at this time. And as they did this, they were actually in the process of changing their business model. Now, before this, they had a leadership through quality model. The leadership through quality model was very much focused on how quality disciplines fit together and how they merge. And so they moved then into what's called business excellence. And this business excellence model was actually applied to win the EFQM Quality Award in the very first year. And Xerox had disclosed it there. EFQM liked it so much they changed from the European Quality Award to a business excellence model. And that model then became the basis for it. That model is described in a book that I wrote when I was with Xerox, and it was called A World of Quality, the Timeless Passport, in which Xerox talked about its evolution of 25 years from the very first Deming Prize they received at Fuji Xerox, to the Baldrige Prize in the US, to the EFQM Prize in Europe, and how they had gone through 3 different levels of change of their organization wrapped around quality. So what is leadership through quality? What does it mean, and how will it continue into the future? Well, leadership through quality recognizes we have to have quality management. It doesn't go away. Just because times change doesn't mean that the fundamentals are not essential. We also have to have quality development. We have to plan for the change that's going to be happening in the system. As new technologies come aboard, how do we adopt them? We're having this questioning right now with something called Quality 4.0, or how do we move digital technologies into the quality sphere? And then thirdly, we have to have a quality culture. We have to have a coherent way of people thinking with a common mindset and a common way of acting in the organization. And this is what we mean by leadership through quality. That leadership through quality is not just about collections of tools, it's about ways of being, of ways of acting coherently, consistently as an organization. And this is engineering quality leadership of the management in the organization. And what this approach does, it assures sustained success of our management system. And that's what we would like to be able to have over the long term. Now, I left Xerox in 1994 because of cancer, and I started a consulting practice. The very day I left Xerox, HP hired me to do a project. And the task was to determine what would be the quality characteristics important in 2010. And one of the studies companies we studied was Nokia mobile phones. And at that time, Nokia was producing 100,000 GSM phones annually. That's about the same volume that we were producing of the PaintJet products. And over the 5-year period of consulting with them, that volume increased to 200 million phones for a single model in 1 year. And so you can see that that is an 86% compound annual growth rate. It's exponential. And so what we see is that in that process, Nokia could not do that with a linear rate of change. And in many cases, you'd say that was chaotic, but it wasn't chaotic. It was planned chaos. So for instance, we re-engineered the R&D process 3 times, reducing time to market from 2.5 years, 2.5 years, to 12 months. And this was driven by 2 concentrations, one on innovation and project management, and the other on quality. And we coordinated those with a Hoshin Conway-based planning system. So Nokia mobile phones developed its own unique quality system. And what's important is that that unique quality system did not follow what they said in the European Quality Award, but when they applied for that award in 2001, they received the highest ever score as a consensus score out of the examiners. So each examiner scores independently, they get together and they come to consensus. So out of consensus, usually the scores go down. But if they went down, that's a pretty high score. Never before have I seen a score like that. Normally a winner of the European Quality Award will be in the 600 to 700 point range. And so they were doing something excellent without following the criteria. And what I think this illustrates is that the criteria are guidelines. They are ways to think about it. And can you then take those criteria, whether it's the Excellence Awards or whether it's ISO 9000, and then fix your system of quality so it does what you need to do for your business and have an innovative approach to it. My second consulting client after this was an 18-month project for Taizo Nishimuro. He was chairman of Toshiba. He brought me to Japan for 11 extended visits, and I also had engagements in Europe, South America, United States, and I was teaching what they called management innovation. And then in that, we were using the Six Sigma method for structured improvement. Now, management innovation was what they said combined 5 activities into the managerial re-engineering, if you will, of Toshiba. So they changed all of their business language from Japanese to English. And what that meant was actually of the 36 executive senior vice presidents, half of them had to retire because they didn't speak English. They shifted the accounting system from a Japanese system to a US system because they realized that it was hurting them in terms of how they did pricing into the US. And they were always being complained against as being a price dumper. In other words, they're dumping products in the US at a lower cost than what it could be made if it was done in the US. They also developed a core of what they called top runners, people who would be executives in the future. And those people all had to have worked in an English-speaking country. They had to have bachelor's and master's degrees, preferably engineering and management. And they also then had to qualify as black belts and then master black belts in their continual improvement system. So we trained 60 of those people. How good is that? Well, 2 of them are presidents of different parts of Toshiba today, and one's on the board of directors. And then we see that they customized, it wasn't called Lean Six Sigma, but believe me, they were very lean as a Japanese company. They've been working with the Japanese Productivity Center. They had total quality control implemented in the 80s. They'd won the Deming Prize, and they rebranded it Management Innovation. They didn't train black belts. What they did was they trained quality experts and senior quality experts. And so they created this, and they created an engineering function called Toshiba Technical Services. And that was the centralized engineering hub where they could apply this intellectual property throughout the corporation. Now, what we saw at this point in time was that there is a building of an integrated management system. There's a strategic linkage, business excellence, questions that senior management can use for self-assessment. There's a baseline level, this operational linkage around quality work standards. And then a consistent portfolio of projects that can be done in a sequence of activities. So one project at a one project change at a time to improve based on self-assessment that gives me the internal view, and benchmarking, which gives us the external view of what needs to improve. And project by project, the steps go from standard work into this level of exceptional performance as an aspiration for where we'd like to be. Now, I left there and Toshiba, and while I was actually at Toshiba, a couple of gentlemen from ExxonMobil came and found me in a smoky bar, and they asked, questions to interview me. Could I work with the executives at ExxonMobil? And so they had decided that the board was making a choice to implement Lean Six Sigma as a methodology to sharpen the blunt instruments over their continual improvement process. And I remember going into, they chose Canada, Imperial Oil of Canada, as the pilot. I remember going into my meeting with this president of Imperial Oil of Canada, and his name was Robert Peterman, and he had it was his 119th monthly executive meeting on continual improvement. And he says, we're not changing this. We're not going to do anything different. We'll just sort of use the tools and that's it. And as the result of that meeting that went for a couple of hours, they changed the name of their program from Continual Improvement to Accelerating Continual Improvement. How do we put it on steroids? How do we boost it up and get it so we can get more scientific instruments and tools into the hands of the workers to make change really happen? And they were the pilot chosen. We did 3 waves of black belt training, 25 black belts per wave. We developed out of that group 9 master black belts, and they internalized and adapted the training to the way it works in the ExxonMobil culture. They had actually just completing the merger at that time. And then, so how will they evolve in the post-merger world? Now, all of these were coordinated, and they helped make ExxonMobil the most profitable company in the world during those early 2000s. And further extensions of the methodology were managed internally by the master black belts without further consultant support. I came back a couple of times there to meet with people, but it was not to teach. It was basically just to review and to give suggestions. So at this point in time, we see that Six Sigma is coming about. Now, Six Sigma had matured over this whole period of time. Bob Galvin in 1985 was at a management meeting. His vice president of marketing said, our quality sucks. HP is killing us because they've been implementing a 10x quality improvement program since 1980. And now we can start seeing the impact. And Bob Galvin got rather upset. He said, if John Young, the CEO of HP at the time, where I worked there, if he could do 10x in 10 years, we can do 10 times 10x in 5 years. And so that's what he called for. So that's basically 100 times the quality in just half the time. And so what that was then is an exponential function. They didn't know what that meant. How do we measure it? Bill Smith came up with the idea saying there's an exponential measure. We're going to call it sigma, and we need 6 of them. So they created the Motorola Research Institute in 1988 to figure out what's the methodology. Now that's the year they won the Baldrige Award. They did not win the award because it implemented Six Sigma, but because they put that as a corporate challenge to themselves and to their suppliers. They received that same year this Baldrige Award, and then they applied to this methodology to a customer. At the same time, they were doing it internally. They hadn't learned how to do it yet, but Unisys wanted to understand how to do it. And so they tied it at Unisys. And in 1991, the CEO at that time, George Fisher, wrote a letter saying, we have completed our program. We've received a 5.1 Sigma result company-wide, and we've had 2.1 billion in documented savings. ABB at the Transformer division applied it in 1992-93. Michael Harry left his consulting work with Motorola, became a vice president at ABB for that period of time. Allied Signal then heard about this as a need. And so the former head or number 2 person at General Electric had come in place, and he became the CEO of Allied Signal at the time. And he was too old to become the CEO to replace Jack Welch. And so he looked for his own company. And he came in there, and the chairman of the board said, there are 2 choices. You can either turn around the company or you can break it up and sell it off. And that's what you have to do. So he chose to turn around the company. And so that's what he did. And he chose Six Sigma as the way to do it. GE implemented Six Sigma at the end of 1995, just months before Nokia mobile phones did. And so when those 2 companies had implemented Six Sigma, there were no more instructors in the world. And this basically delayed, there were only about 12 people who could instruct Six Sigma. And GE then at 1997 added Define to the program. So when GE put this, Motorola put this together in 1988, it was only measure, analyze, improve, control, and you do it to everything. It was kind of like a PDCA model. It wasn't formally structured in the business management process. GE said, no, we have to have management involvement. We have to control that. So we added the Define step. And then in 2003, Michael George came in, and he rebranded Six Sigma as Lean Six Sigma. And his company, before this point in time, had been working on just-in-time and lean production systems, lean automotive systems that came about from Womack and Jones and their machine that changed the world in 1991, I think that was, in 1995, lean thinking, and that started getting its own momentum. And so he said, oh, I can take over this system, and he did. He's a very clever marketer, but what he did was he dummied up the Six Sigma programs, if you take a look at them. So they then switched from a lot of the multivariate statistics and made it more of a lean process. And so that was one of the transitions. So if we look at this whole system, we see there's a need for a continual improvement culture. It has to have 2 components. One is incremental improvement and one is breakthrough improvement. The incremental improvement operates at 3 levels. The standardized do, check, act daily management system and the plan, do, check, act or Kaizen events are both about process thinking. And then we add the lean thinking, which is in the Kaizen events, and that's basically a lean focus. The DMAIC projects are adding statistical thinking into that, and that's now the statistical focus. When we take a look at breakthrough, we're taking a look at design thinking. And so that is what a DMA, DV, or design, define, measure, analyze, design and verify and validate project. That's design thinking. That's sometimes called design for Six Sigma. So Lean Six Sigma is all of that. And I want to emphasize this. It's not Lean or Six Sigma. It's all of it together as an integrated whole. You cannot do one or the other. You have to do them both. Because if you start taking a look at Lean only, then how do you know what to lean? You know, do you lean everything or do you have priorities? So you have to understand the work, but you also have to get the process to operate consistently. So you need to have statistical methods to be able to do that as well. So this is one of my favorite Japanese haikus, and it's by Matsubasho. And he says, "Do not seek to follow in the footsteps of the old masters. Seek instead what these masters sought." In other words, don't try to do exactly what the masters said you should do, but instead understand why were they doing these things and what was it that was necessary. And so if we take a look at the organization, if you've heard me speak before, you've heard me talk about the 3 levels of Gemba. So Gemba is basically the workplace, and organizations have both operational Gemba and administrative Gemba and governance Gemba. And what we see is that the foundation for change is control. Standards are required. And when we come to this incremental improvement, we have to have the standard that we manage. That's SDCA loop. So that is the process of improving routine work. And we also have 2 jobs in doing this. We do the work and we improve the work. And then when we can't improve it within our control, then we accelerate it to get management's engagement. And that can be just the frontline supervisors, but that means that's beyond the capability of the workers to do themselves. So that means they need decision rights, they need to have additional responsibilities given to them, or they need to have resources. And then they can enter the PDCA cycle. When we start seeing this Gemba 2, we're talking about the organization level that is actually going to be making a strategic change project so we can run Gemba 1 better. And this is change as breakthrough. Maybe we're bringing new technologies in, or maybe we're doing a business process re-engineering or engineering a process for the first time. And if we're going to Gemba 3, we're talking about change as transformation. This is, we're running the whole business differently. So digitizing the business, changing the culture of the organization. And this is where we see now we've moved from SDCA, PDCA to Lean Six Sigma, DMAIC, and DMADV up into the continual improvement process. So some of you may have been involved in the continual improvement development program, and this is where we teach this. Now, the reason we add this is that there's a lot of things that are the same, but the characterized step here at the front end, that's like the strategic alignment. Where do we need to change? Define something, that's an outcome of this, and that's like the investigate. We're choosing to investigate this. And so then we investigate, explore, we solve, evaluate, implement. And the problem with control in Six Sigma is it does not actually move it into action and monitor it over a long period of time. And so in monitor, we move it into place, we enact it, we transfer it to daily work, and we operate the SDCA cycle. And so the SDA cycle is actually embedded inside that monitor process. So we've extended both the front end and the back end of DMAIC, and we've made it a more generic model. And the reason that it's important as a more generic model is so that any organization, any discipline can pick the model up and not feel like, oh, I have to do that techie thing. And they can define the tools and the methods that they use underneath it so it fits their ability to work. And then they can make the changes to stabilize and improve the standard work in that way. So we've gone through a lot of things. We have just about 5 minutes left. I have a few more PowerPoint slides, but you know, we've gone through a lot of things where improvement has been. And so now let's talk about where it's going. And we start seeing methods and tools come and go. So many of the tools of the past I consider obsolete. FMEA, obsolete. Hypothesis testing, obsolete. Gauge R&R, obsolete. Well, what does it mean about the future? So what we have to ask what's enduring in terms of commitment to management to improve. That's what we need to endure. We have to avoid negative consequences. So where are the why and the what that we need to improve? The how and the where, the methods and the tools, that will change. And the operational aspects of how we make those improvements provide the context for that. So the commitment needs to be constancy of purpose. Technology causes change, and methods and tools, they'll all change. So many of the methods and tools embedded in Six Sigma of a traditional Lean Six Sigma program are archaic because they were developed in an analog age by who I refer to as our quality grandfathers. They were mostly all men. And those people basically were totally incapable of using computers. Ishikawa never had a computer. Juran talked about, I'm going to die with my hands on my word processor, which is an early name for computers from the 80s. I still remember Val Feigenbaum asking me in a meeting, how do you turn on this PowerPoint? So it gives you can laugh a little bit about, but that was their level of sophistication. But what we see today is we see digital technology, automation, artificial intelligence, systems integration. It's a game changer. And in the process, they have obsoleted many of the old methods, and we need to make them over. And maybe your generation can be the ones to do this. And we have to align the technology so that we can define what do we mean in this new age we call quality 4.0. So we start seeing there's a number of methodologies, and you all know them better. So AI, machine learning, deep learning, neural networks, blockchain, augmented reality, all of those change our ways of gathering data and processing data in organizations. They give us different perspectives, so we learn to see differently what's happening in the organization. And what will be the next challenges? Well, we're going to see that the need for this new model for continual, it's generic because it has to meet the needs of all disciplines, all industries. And when we integrate new digital tools in this model, revise and replace the old tools that are no longer appropriate, the ones I just mentioned, like FMEA, Gauge R&R, hypothesis testing, and so forth. And there are many research activities and practical applications to work out. This future is not settled. We haven't decided what it will be. The past is not the prologue to the future. It only gives us a hint. And the next 5 years, we'll see development of new methods and tools, revisions of some old ones, obsolescence of others. So we're living actually in an age of tool turbulence, and we shouldn't be committed to methods and tools of the past in our pursuit of continual improvement. So we don't need to be the tool head, if you will, of the future. Now, I'm going to close off with just a couple of comments. So Yukas had asked me to go over, how did I get involved with Esteem in the first place? So my first contact with Esteem happened in 2010. I was the senior vice president of the Institute for Industrial and Systems Engineers in the US, and I was doing a survey in that capacity of what were the industrial engineering practices around the world. In 2011, I discovered Esteem, by the way. I called up the president of Esteem at the time. He wasn't interested. He said, we're a student organization. And then shortly after that, I started having some more conversations with the vice president from Esteem from Finland, who was out in Turku. And we started then moving forward with building a relationship, and we had a memorandum of understanding in 2011. I discovered a little bit more after going to a couple of council meetings, and I agreed to become a Helsinki summer academy professor. So we did summer academies of 2014, 2015, 2016. And then Yukas basically said, well, why don't we have a Greenbelt course? And that sort of, turned my life upside down as we spent a couple of months developing the 80 videos and PowerPoints and stuff, and then making that available. In 2016, I was elected honorary member by the Esteem Council. And then in 2017, we did the pilot course of Greenbelt training at Aalto University, and we had about 25 students there, I guess. And then in 2017, we also initiated this African CI specialist program with the International Trade Center, and we've had 3 or 4 of the Esteemers join us in that endeavor. Yukas was there with me first. And then we piloted in 2019 this CI specialist development program, and it looks like we'll be continuing that next year with the second wave. 2020, I don't know. We'll just see where we're going after this. So I have some recommendations for you. First, what you're doing in your career, standardize on the generic continual improvement model so there is stability in the core methodology. Every other model can be expressed using that. And so not every model goes the opposite way. So not every model actually expresses that model because they've got weaknesses in them. Seek to understand how technologies will change the way we need to think and act about improvement. Learn the new technologies that will become cornerstones of the emerging areas, particularly machine learning's its extension into robotic process control and adaptive feedback loops. But don't become a toolhead that you cannot see all of the systems implications or get lost in the minutiae of tools, methods, or softwares. Anchor your learning in those historical lessons that have long legs and represent core settled knowledge of the past. If you don't know the past, you're condemned to repeat the lessons that others have already learned. And finally, be skeptical of everything. Be curious to try new ideas and seek first to understand before trying to be understood. Really try to learn what's going on. Spend more of your time listening than talking. The green belt is just the beginning.